Hey, it's Joel, and we are back from Formnext. That was in Frankfurt, Germany. I'd never been before. It was incredible. Formnext is the Industrial Additive Manufacturing show that you just can't miss. And industrial additive manufacturing is so different, yet so familiar to those of us who tinker and hobby around with consumer-based 3D printers. We were there, we got to visit a few booths, and I'd love to show you right here on 3D Printing Nerd. I've heard from many people that I need to look at CraftBot 3D printers. The machines that CraftUnique makes are great because from what I hear, they're built incredibly well and they have this ability to create amazing 3D prints time and time again. We spoke with CraftUnique at their booth at Formnext, and I finally got to see these machines up close and in person, and they were really cool. I can't wait for you to see this one because I think we're gonna get one of these into the studio soon. We got a chance to stop by their booth at Formnext and see what makes these CraftBot 3D printers unique. Have a look. Hey, Christian.
Hi, Joel.
How are you doing?
Fine, thank you. A little bit tired now.
I'm a little bit, yeah. You're a little tired too, aren't you?
Yes, we are tired.
But it doesn't matter because there's awesome stuff here, such as that new machine.
Yes, the new flow generation. Yeah, CraftBot flow generation printers.
It's huge.
It is. It's one of the best and biggest plug-and-play IDEX machine on the market.
Well, let's go over it. So
Okay.
talk to me about this machine. It obviously looks massive in size. What's the build volume?
And the build volume is 425, 250, and 500 in the Z.
500 in Z.
Yes.
Wow.
Yeah,
okay.
so
You have
it's-
a great little UI up front.
Yes, and also it's powered by the Raspberry Pi compute model because it runs on Linux.
That's great.
It's really great. It has a lot of power to handle the camera, handle the speaker, the touch screen, and later on some additional features can be added on.
Well, if you have that in there, it gives you that flexibility in the future for
Yes.
updating things, just in case something comes up that you may not have thought about before.
Yes, yeah, they just ask about if we can attach a RFID reader, then it's no problem.
That's
we
no
just
problem.
Can do that. Yes.
Let's see. Filament is on the back, it looks like. Is that right?
Yes, but you can place it wherever you want. You can see the screws on the top, so it's no problem if you want to place it on the side or in the front. If you have any other places, just do it. It's no problem.
Are the extruders similar to the previous machines?
Somehow, yes. We introduced the all-metal hot end 2 years ago, and now every printer has the all-metal hot end now and go up to 300 Celsius.
Oh, perfect. So 300Z there, and that's a heated bed.
Yes.
Looks like is that Kapton tape on there?
Yes, it's a Captain Tipo that. It's also...
And it's removable.
Yes, it's removable.
Does it flex?
Yes,
It sure does.
It is. It is. Yes, and things go up to 110 Celsius.
Wow. 100C on the bed.
Yeah.
I noticed some cutouts on the front.
Yes.
What is that circle one? Because I would imagine the longer ones are for being able to grab it easy.
Yes.
But the circle one, what does that do?
It's really good you are asking because we are very proud of that solution.
A
So
solution, it's not just a hole.
you can touch the head in the hole in two directions, X, Y, and then touch the hole with the other head, again, with the two direction. And between the two deviation, you know how the two heads are not completely parallel.
I know what you're doing. Oh, so typically on a dual extrusion machine, you have to align the heads, or at least
Yes.
the machine has to know at the offsets at which the nozzles
Yes.
are for proper dual material
Yes,
printing. But
yes.
I'm used to printing lines.
Yes.
You're saying that the nozzle uses that hole and touches it in
Yes.
the different axes,
Yes.
and then it just computes the difference and
Yes, and you are there. It's no more lines, no more counting, no more printing before you start everything. Yes, it's doing like that.
that's a fantastic way to do it, honestly.
Thank you very much. We are very proud of that.
And as far as materials, if the bed goes that hot and the nozzle gets that hot, I mean, you can print the standard assortment of PLA, ABS, PC, ASA, PETG,
yes.
TPUs. Can you do flexibles in this?
Yes, because the dual drive extruder we are just developed, it's very capable of flexible filaments.
Dual drive meaning it grabs it from both sides?
Yes, too, and there is a 3-to-1 transmission also, so it's very strong.
Oh. Could you, if you had filament hanging from the sky, could it lift the machine up?
Yeah, we wanted to try it out and make it on the YouTube. Yes.
Is this shipping now? Is this available? This seems like a wonderful package that someone might want.
Yes, we just started selling these printers in this exhibition. So pre-orders are already made and the production is underway in our factory.
Oh, that's great. Wait a minute, I just saw something.
Yes?
Is this an example of what your hot end is?
Yes, sure. Should I hold it for you?
Sure, but I'm curious. So this is the nozzle,
Yes.
and the nozzle goes all the way through the heater block.
Yes, that's right.
And then this is the
heat break.
heat break, and it hasn't. So the nozzle screws into the heat break.
Yes.
Oh, okay.
So
That's an interesting way to do it.
The heat block is evenly can heat up the filament inside the nozzle. So no connection between the two material inside the heat block, which can make some oozing or some problems with the clogging or something.
I see. So the heat is evenly applied just to the nozzle.
Yes.
And then the nozzle touching the heat break, is it what material?
It's titanium.
Ah, okay. So you're not getting any heat transference up here.
Yes. Also, it's narrowed down, so the cold end of the hot end and the hot part of the hot end is not interfering with each other.
That's really cool.
Yes, it is.
Oh, wow. Well, thank you for this tour. I really appreciate it. This looks like a
Thank you
fantastic
very much.
machine.
Thank you very much.
Maybe I'll get to try it sometime.
Yes, definitely you can. We will provide you one.
Thank you.
Welcome. We are welcome.
Typically, any 3D print you get from a powder-based system isn't going to be a finished product. It's going to look really cool, but it's not a finished product. What DyeMansion offers as a service is a way that turns those powder prints into finished products. And it's incredible what they do. We spoke with Pia at their booth, and she took us around and showed us some of the things that they're able to do with their service. I was blown away. I can't wait for you to see this one. Have a look. Hey, Pia.
Hi, Joe. Welcome to the DyeMansion booth.
Well, thank you. It's a fantastic booth. What do you do here at DyeMansion?
So we at DyeMansion, we turn 3D printed raw parts into high-value products. So basically everything that comes after the printing step.
And we're not talking about the stuff that I do at home on consumer level machines, right?
No, we're talking about the industrial level. So really for powder bed fusion parts like SLS, MJF, FDM parts at a big scale.
Okay. Well, is there anything you can show me that that this has been done to?
Of course. So one of our biggest applications is eyewear, definitely.
Oh,
so
I'm an eyewear fan.
Yay! Yeah. So this is why there's so many eyewear frames already finished with our technology. We believe there are over 1 million at this point.
Really?
Yes. We kind of unlocked this application with our surfacing and finishing technology.
May I?
Yeah, sure.
So this is powder bed printed, right?
Yes, yes.
And then using your technology, you were able to finish this, and that makes it a finished product at this point, right?
That's right.
The finish is exquisite, and the look is great. So what happens? Do you take this part and put it in a machine and your process does something?
Yes, for sure. So when it comes out of the printer, it's white, obviously, and it has a very rough surface.
Right.
What we now do is we remove the powder, automate it, and then we treat the surface with like a mechanical process. So the pores are closed, the surface is more homogeneous, and then also the dye penetrates in a better way. And then our customers, they can choose any color they like from corporate colors to trend colors.
Maybe blue?
Blue would be fine. I think this one is blue. Look at this.
Hey, there it is.
Would you like to try that?
It's blue.
Not too bad.
Yeah?
It suits you well.
Yeah. I don't know. We might need to make a larger pair if I'm going to be rocking these for a little bit longer.
That's the good thing about 3D printing, right? We could even customize those.
That's right, we could.
Yeah.
Well, what else can you show me here that your process has finished?
What else do we got? So here we got the first 3D printed shoe ever. Under Armour ever, the first. So Under Armour put that on the market in 2015, I guess. And we also do the coloring here. So they wanted back then their corporate color. This one is called Glacier Gray, and you see it really fits to the fabrics around it.
Oh, I see. Yeah, very good colors on that. Well, we got some other stuff behind us. Let's go take a look.
Let's go.
What is this that we have here?
So yeah, this will be an industrial application. It's actually a scanner to scan your inventory. Look at this. You can scan barcodes or QR codes with it.
And your process actually finished this, and did it put the words on it?
So this one is afterwards. I think it's just like a sticker.
Okay.
Yeah.
This looks neat, and I would imagine that your technology is cool because obviously they're going to want to brand their product with a color, and thanks to your technology, then they can do that easily.
Yeah, for sure, for sure. So we developed their orange tone, and they have it here, for example, or at this case, or even the charger is colored in orange, so it all fits together.
That's great. It's a complete product at this point.
Yes, for sure.
There's more examples over here. Can we go take a look?
Yeah, let's go.
What are we looking at here?
So that's a new technology EOS just launched here at the show. It's called Fine Detail Resolution for even finer details. And I want to show you this. Look at this, it feels so good.
Wait a minute. This is printed.
Yes, it is.
It feels cool in my hand.
Yeah, it feels so smooth, right?
But these details are crazy. And it didn't come out pink from the EOS machine,
no,
right?
No, obviously not. It came out white.
So how does your process maintain all of the detail in something so small?
So the good thing about our process, our dyeing process, since it happens in a water bath, it saves all detail and it does not change the geometry. So the parts are thrown inside a basket, the basket is filled up with water, and then the dye stuff really penetrates the part. Yeah, different than spray painting, no additional layer, and every detail is saved and
no
not
additional
changed.
layers?
No, not at all.
It's so tiny, like I can't comprehend. And what's crazy too is once this was printed at some point, I would have looked at it and said, wow, this is cool. And now you've actually, without adding anything to it, you've made it pink.
That's right. And it's neon pink. It will even glow in the dark.
Really?
Yeah, it does.
Of course. Oh, look at that. You can actually, there's a logo in it.
Yes, it's EOS actually.
Can you see that?
Can you see us behind it?
Well, this is incredible. And I love that. I love that this is something that you can do to the material without changing its physical properties.
Yeah.
Neat. I'm seeing one more thing over there, though. Can we go take a look?
Yeah, let's go.
That looks like a prosthetic there, and your process was able to finish it?
Yeah, for sure. So this leg is scaled down a bit, but it's a tailor-made piece and it's unique to the patient. So the patient is scanned and then he gets his own leg prosthetic, and yeah, we dyed it. So look at the nice surface finish.
The surface finish is crazy. It doesn't look injection molded because it has a matte finish on it. That's fantastic.
Yeah, and I know from our customer Göttinger that some patient even go swimming with it.
Really?
So it's totally fine. So they go swimming and paddling with it, and it works.
So your process that dyes material isn't affected by the water?
No. So it's not the dyes are not washable anymore after the process is done.
That's really cool. Well, talking about the color though, we have this next piece. That is a hand, but it's a very specific color, right?
Hello.
Hello.
So with our technology, we are even capable of scan your skin tone, for example. We did this with a colleague's skin, but in reality, the customer would do that as well. So it's a surgical, it's a plastic surgeon, and he uses that as kind of prototyping parts for his actual work. So he will show you, okay, this is how your hand will look like after I'm done.
But that's great because part of what makes this special is it's very customized for the user.
Yes.
And being able to see a finished product or what something should look like in your own skin color, I think is a great way to do it. So that's fantastic.
Yeah, and especially in the medical industry, so the own skin colors of the people help them to accept the aid better.
Well, and finally, that's a flexible piece over there.
Yes, that one is also nice. So
you're able to finish flexible materials.
Yes, we did that with a system we just launched here at the show, and now we're finally capable to also finish TPU and other flexible materials, so that they really get a sealed and washable surface, which look pretty similar to an injection molded surface.
Very similar. Like you said, it makes the surface homogeneous and seals the pores, and well, it looks incredible. I've used TPU before in printing on consumer and hobby level machines, but you know, I'm not finishing that. I can't sand my TPU.
Yeah, that's right.
But now I guess I can get a better TPU print.
Yeah.
That's really cool. Yeah, I want to say thank you very much. I really appreciate the tour.
Thanks for visiting.
The Raise 3D booth at Formnext was quite busy, and there's a good reason for that because they were showing off their latest machine, the E2. It's a bit of a departure from what they've offered in the past with a shorter Z, but dual independent extruders. They've also changed the user interface a little bit to make 3D printing with the machine easier than ever before for those of any age and any skill level. I really get the feeling you're going to start to see the E2 in the education segment. I stopped by the Raise 3D booth for a hot second. Have a look. Hey, ow, I got shocked. Hey, this is the new Raise E2. I've heard about this machine, and I know that most of the Raise machines are big and tall and take up lots of room. This one doesn't seem to be. It almost looks like a microwave oven. Oh, this is cool. I don't think anyone's around. They must be busy. I guess I get to play around. Okay, it's got the same UI, it looks like. Let's see. Okay. It's got a great UI here, and it looks like it's the same sort of touch screen. I can pause, I can stop prints. Oh, look at this, look at this. Inside, this is actually new for Raise because it looks like it is a dual independent extruder. And I guess it's going in duplication mode. That's my guess. It looks like it's printing the same thing on either side. Oh geez, the extruders look new as well. That's a new design. Oh, and filament is on the side? Okay. What happens if I open the door? Oh, look at that. It pauses the print. Oh, look at this. Ooh. Okay. Well, no one's around. Maybe I can do this. I'm gonna hit that, and I'm gonna stop it. Look at them. Okay, they lift up. Good. Okay. I think, look at this. This is a removable, flexible build plate. Oh, this is fantastic. I'm really glad that this machine has this. And then just put it back in. Oh, it presents itself. Thank you. Okay, it's stopped. Wow, look at that. Oh, and there's a filter in the back, and it opens up on top. Geez, it looks like the filter's working too. I can actually see some dust and debris that it's collected and it hasn't shot out of the machine. So that's important when we're talking about education and different STEM and STEAM programs because filtration is important. All right. Wow, this is actually, okay, this wasn't what I was expecting from Raise. This is actually kind of neat. I hope to get my hands on this pretty soon. Oh, okay, people are coming. This was a lot of fun. We'll see you in a bit. Getting stronger prints is one of the tenets of industrial additive manufacturing, and Desktop Metal's latest offering, the Fiber 3D printer, is aiming to make that easier than ever before. The Fiber uses continuous carbon fiber tape inlaid into 3D prints, which makes them stronger than you would believe. I was given a piece and I couldn't even flex it, let alone bend it. We spoke with Rick, their CEO, at their Formnext booth. Have a look. Hey, Rick.
Hey, how are you, Joe?
I'm doing well, and part of the reason I'm doing well is because there's this new machine that's next to you that Desktop Metal has.
Yes.
And I would love to hear more about it because it seems to be almost game-changing in nature.
It is. It is an amazing machine for carbon fiber printing. Continuous carbon fiber printing.
Continuous, meaning there is a continuous carbon fiber strand within
Absolutely.
the material.
It's the first machine that uses AFP tapes in a 3D printer in a desktop at an affordable price. This tape is the same type of product that you put inside a jet engine component or a wing spar or a fuselage. It's got the best material properties. It's called AFP tape. Usually it's millions of dollars to actually put AFP tape inside a product. huge investment in capex of machines that do this.
Well, it's for airlines usage, or
It's for aerospace,
I mean, I would
or
imagine that would be expensive.
marine or other applications. And for the first time, we're bringing it to the desktop or to an affordable, a machine that everybody can afford.
AFP tape is within this.
Yes.
As well as what is the surrounding material?
You can put PEEK, PEC, nylon, all sorts of
All the
advanced-
good stuff.
All the good stuff, yeah.
What's the price tag on something like
It
this?
starts at $34.95 a year.
So a year. This is interesting because it's
Yeah.
it's like a hardware subscription, right?
It's a hardware as a service. You're never stuck with obsolete hardware. You get service and software updates every couple of weeks. So it's a continually evolving machine, has a tool changer, so you'll eventually have metrology, part inspection, more materials, lots of options.
So with the tool changer, and I think I was mentioning this before, we have the ability now with this machine, then
Yep.
we can use not as expensive materials to prototype,
Yep.
and then using the same machine, go back and do an AFP tape inlaid part that's a final part.
Yeah. Although it's still very affordable.
It
the whole
is?
thing. Yeah.
Okay.
It's a great solution.
Well, here, I have this in my hand. What is
Sure.
this tiny little piece costing you? A couple pennies?
Maybe less than $1.
Okay,
Yeah.
we'll say less than $1. Well, and it doesn't even, well, here, hold this for a
Yeah,
sec.
sure.
I just want to show. I mean, I am putting effort behind this, a lot of it.
This is twice as strong as steel and half the weight of aluminum.
That is,
It's
That's nuts.
Much better than any, in terms of mechanical properties, much better than any other 3D printing process that's available on the market.
well, this is important, what you just mentioned, a 3D printing process. And
Yes.
so we have a world of makers who are in their garage or tinkerers or hobbyists.
This is affordable.
This is not
This
as,
can go in a basement.
this is not, exactly, this is affordable, but
Yeah.
it's using a technique that everybody knows who's already doing this.
Yeah, it's a fantastic product. Yeah, we should show you the parts.
Yeah, let's go see them.
Excellent. I'll follow you. Awesome.
These are the parts, right?
Yeah,
Okay, let's start over here. What are these parts and why are they awesome?
different types of jigs and fixtures for manufacturing. One of the really exciting things is the surface finish technology that we've implemented in this.
It looks
Yeah.
injection molded almost.
Yeah, for an FDM part, this is the surface finish that you get with our process, which is really good.
The top layer has no layer lines. Like there's
Exactly.
it doesn't even look like it's been ironed per se. It
Yeah.
looks like a single part, like a
Yeah.
single piece.
And it's part of the special technology we've developed.
And these are all printed, right?
All
of these
printed,
pieces
yep.
here. These are all jigs. That looks like for a bicycle.
Yeah, that's a bicycle crank.
Okay.
Yeah, you can print fiberglass, continuous tape. You can print carbon fiber, continuous tape. You can print PEEK and PEC with chopped fiber, so high temperature materials with chopped fiber. They can withstand continuous use up to 250 degrees C.
Peak with chopped fiber.
Yeah.
With AFP tape. I mean, there's nothing stronger
That's
that's
it.
been printed at this point.
It's badass. Yeah.
And these are all just some jigs. That probably
Yeah.
holds something. What is that?
That is part of a race car. The exhaust, it used to be made out of steel because it gets hot.
It does.
And it's now a PEEK part with tape inside. Yeah, it's pretty awesome. It's super thin. It's very stiff. Continuous operation up to 250 degrees C.
That's
It's
amazing.
It's in one of the BMW race teams in a
Oh, really?
a vehicle.
I should probably inquire within because
can
I'd love
send
to
you-
drive one of those cars.
I can send you a picture. I can arrange it. Yeah. Where do you
Don't-
live?
Far away from BMW.
Where do you live in the
We're in
States?
Seattle.
You're in Seattle. Okay, if you come to Connecticut, they'll race in Connecticut. So
Deal.
And you
Deal.
can
You
come
heard
probably-
it. Connecticut.
Yeah,
I get
yeah.
to Connecticut.
yeah, I'll get you in the car.
So we've got parts here that are incredible, but there's this other new machine over here that's producing some pretty neat stuff as well, right?
Yeah.
Can we take a look?
Absolutely. Let's do it.
Fiber looks to be impressive and priced at something that someone could afford to have in their garage.
Absolutely, yeah.
This looks to be a little bit more expensive. What is
Yeah.
this machine and what's it doing?
So this is the shop system. It's the world's first binder jetting system designed specifically for machine shops.
What makes that special? So binder jetting, I mean, we have binder jetting in other machines.
Sure.
This one though for a shop, meaning
Well, it's affordable and it has very, very high resolution. This has
Okay.
the highest resolution print engine ever put in a binder jet machine. Drops as small as 1 picoliter. And,
that's nothing.
and 1600 DPI, which is 35% more than our closest competitor. 5x redundancy, which is 25% more than anybody else has ever done in a binder jet system.
Wow.
And it can do a whole batch of parts in a very short amount of time. It's incredible.
So you could stack the bed with parts, hit it go, and then you come back the next
come
day?
back and then you center your parts and you're done.
That's amazing. What's
Yeah.
we're talking metal parts here then?
Yeah, metal parts, all sorts of alloys, stainless steels, Inconels, all sorts of things. High performance materials, copper.
So, okay, the shop system then, give me an example of what what one of your customers may be. Like a machine shop doing custom work for automobiles, or maybe a motorcycle repair facility?
Medical, aerospace, any type of high-end machine shop that would have lots of CNC machines. This is a really productive way to prototype complex parts that would be incredibly difficult to machine.
I see. So we're utilizing then 3D printing to make geometries that would otherwise be impossible.
They'll be cheaper to make this way than machining. They'll be much faster to make this way than machining.
And just as strong?
Yeah, it's the same alloys, same metals. So actually, if we show you some parts, you can actually see that you need many setups to do something with 5-axis, and it would be so slow compared to what you can do in a day with this system. So it would totally change the economics of the modern machine shop.
Well, and we're talking about loading up the bed, so we're not just having a layer of parts. We've
That's
got
right.
parts on
It's
parts
production.
on parts.
You can produce parts as a machine shop cost effectively here and go head to head with CNC. You may need to retouch different areas, but then you end up with like incredible geometry that would have been impossible to make otherwise. It's awesome.
That's really cool.
Yeah.
Rick, I want to thank you for this tour. I really
Totally.
appreciate it.
Fantastic.
Back in 2016, I was one of the fortunate few that got to test the Sigma, a new entry into these 3D printers that we use that used dual independent extruders and a large build volume that utilized an A4 sized build plate. It went through a few iterations and we ended up finally with an upgrade to the Sig Max. But that's not where they stopped. BCN3D just released the Epsilon, which is borrowing some of the familiar features from the Sig Max, but upgrading it in ways that, well, you will just have to see to believe. We chatted with Eric at the booth. Have a look. Hey, Eric.
Hey,
How you doing?
fine. Quite busy.
I would imagine.
Yeah, a lot of people in the show.
A lot of people, but a lot of people because they're interested in your new machine that's right there.
Yeah, that's why we are here. I mean, with big stuff to introduce the people the new Epsilon. So yeah, a lot of attraction for the new printer. The feedback so far is being good. So yeah, quite happy.
That's great. Well, one of the things I first mentioned, we're standing next to it, and it's printing, but I can't hear it at all. Now, I'm going to ask you, can we open it up? Because the enclosure might be canceling some of that noise, right?
Yeah, sure. Actually, let's open it. There's a safety pose feature disabled because everybody's opening the door.
Well, we don't want to be safe at Formnext.
Of course. Yeah, you can check the noise if you want. Actually, we're printing with polypropylene here, which, well, having the build chamber closed helps, but yeah.
It's a neat machine. It looks larger than the Sig Max. How much has changed since the Sig Max?
Well, many things have changed here. Obviously, the volume, it's twice the build volume of the Sig Max. We have included as well the closed build chamber. That helps a lot with technical materials. We're focusing on real applications here with technical materials like ABS, PP, PA, carbon and glass reinforced materials.
Okay,
so that's
for
basic.
It's not actively heated, correct?
Not actively. We are warming up the environment with the heat generated by the heated bed, so we can create the right atmosphere. Stable over the time.
When you open the door, I could feel it a little bit, right?
Yeah,
There's a little bit of heat there.
Yeah, of course.
And for materials, you're saying we're not over. It's 300C-ish on the hot end. Is that about right? Okay.
So we are not in the peak peg range yet, but you can print. Up to 300 degrees. A lot of technical materials for real life applications.
Well, I think a lot of people for this sort of machine, I would imagine, would be looking at the nylons or the fiber reinforced nylons or ASA materials, stuff like that?
Yeah. This is one of the major applications. I've been talking to a lot of people during the show, and they have some sort of experience in 3D printing, but they always stick to PLA because every time they try to print something different, they struggle and say, I keep with PLA. We want to change that perception of, printing with technical materials is difficult. You can do it if you have the proper conditions and the proper ecosystem.
I like what you're saying there because, I print with a lot of PLA. It's a wonderful material, really easy to print with, but making non-PLA materials easier to print right off the bat, I think is really going to expand the range of what people can make.
Yeah, of course. That's the goal. We cannot do it alone. We need good partners, so that's why we are working closely with MCPP, a group of Mitsubishi Chemical, and BASF. So we have the good combination of profiles, software, printer. So yeah, it's a good starting point. Of course, more materials will come in the coming months. So let's receive feedback and see which materials really make sense for this printer.
You mentioned software. Is it still BCN Cura? Is that correct?
Yes, right. We're still using BCN3D Cura. We have a release coming out in the following weeks that is including all the new features cloud related. So now the user could, in Cura, BCN3 could log in and send the job files directly to the printer. Select which printer in case they have more than one, and also you can check from any mobile device or from anywhere from the browser. You can see the status of the printers. You can see here the BCN3D Cloud. This is something we are putting a lot of efforts on developing because we really believe the cloud is like the future to provide a good service, a good platform to go for the information, to receive recommendations from our part. And yeah, this is just the starting point.
So with this though, a cloud-based solution, we're talking about now like almost a service bureau management system where people could have multiple Epsilon machines in their bureau and printing for people.
Of course, that's the idea. Also, we have detected that most of our customers just have one printer. So the idea is we want them to set up teams with a shared resource, the printer, so multiple users can log in and with the same printer can arrange their jobs and organize all that printing stuff that is huge sometimes for professional applications.
Right. Well, that's an educational use case, right? We have maybe one machine in a classroom with many students,
for example, or for us as engineers, actually we are using this at the office. We have the printing lab. And all of us have a user, and we can send the job files, so the lab managers can print, but everything from the cloud. It's easier to manage.
Well, that's great. It looks like you have quite a machine on your hands. Can we dive deep into any of the technical details?
Yeah, of course.
I see some stuff back there. Can we go back?
Let's go.
Okay. It looks like you have a display here of some of the changes that you've made to the Epsilon, right? Well, let's go over these. First, it looks like the heated bed's different.
Yeah, definitely. We have changed, first of all, the source of the heat. We are using now a silicone pad, so we can reach 120 degrees in less than 10 minutes. Also, we have an aluminum plate to evenly distribute that heat, so we have no cold corners.
That's good.
Yeah, that's super important, especially with technical materials like ABS. So we have no longer a magnetic bed. You can see the notches here.
I like those notches.
Yeah,
makes you taking it out real easily.
It's pretty handy. User experience is always important.
So one of the things you've always had, the little markings on the dials to know how far to turn.
Yeah.
That's really handy, honestly.
Yeah. Otherwise, you get lost with some ease and you don't know how much
turn
turns.
35 degrees. It's like what?
You have to take the calculator and yeah.
So this is your Z-axis here.
Right. We have changed the key mechanical components. Now we have thicker rods, better. We're using top-notch components for all the guidance. A stepper motor that can handle higher axle loads, so stiffer design as well. It's important.
So it's one motor and it's still cantilever.
Yeah.
And I mean those rods are huge, and the motor can still handle a full load.
Yeah, of course. Also, we have CNC machined blocks to properly assemble, and also to bring some more sturdiness to the frame, because now it's huge. It's aluminum frame, but still it needs to be reinforced. So these blocks helps a lot. Also, it's convenient for assembling after sales service. It's a good improvement.
I like this a lot because before in the Sigmax, this was not a solid piece.
Yeah.
And that is a solid piece attached to the aluminum frame is really going to make things rigid.
Yeah.
Well, what's next over here?
Okay, so about the electronics, we have the same motion board that in the Epsilon, than in the Sigma and Sigmax.
Okay.
But the point is now we have a computer embedded on the Epsilon.
So you're running embedded Linux, right?
Yes, right. We have a distribution of Linux. We are working with Qt as well, so it eases a lot the development of the cloud solutions and all the embedded. So for future products, that's also very convenient. So we can change the module and have more power with a very low investment on development.
That's great.
And yeah, I mean, having a computer inside opens the door of multiple features, multi-language, over-the-air updates, etc., etc.
Well, it's just with something like that, you can now develop features that you may not even be thinking about right now. It's
sure.
very future-proof.
Yeah, it opens the door to new stuff. We are always open to receive feedback, and we try to understand what customers are really needing. I mean, we don't want to develop stuff because of developing. We want to solve problems. So, in case some customer have a good idea, please let us know.
Well, this is the last one on the table here. This is your x-axis, right?
Again, the same with the z-axis. We have improved all the mechanical components. We are here using genuine Hewin linear guides. We have improved the sturdiness of the subassembly. Now it's easier to assemble as well. So yeah, it's important to have good mechanical components. If you are working in a warm environment, we can reach up to 60 degrees. So we have invested on all the mechanical stuff.
Right. With such a build volume on this machine, and especially with the enclosure keeping it nice and warm on the inside, I mean, you have to make sure all of your internal components can perform, and it looks like you've made some upgrades that really ensure that.
Yeah, definitely. Super important. Reliability is I mean, it's a basic. If you don't have a reliable machine, you're done. So we have invested on components and making sure that everything can run smoothly.
Well, this is great. Thanks for the tour, and I wish you the best of luck with your new machine.
Thank you very much.
We got the chance to stop by and see Loctite, and when you think of Loctite, you think of a company that makes stuff that adheres things to other things. But Loctite is now entering the additive manufacturing category with some very specific resins and accessories for post-processing your prints. We chatted with Oscar at the booth. Have a look. Hey, Oscar.
Hey, Joe.
What's your title here at Loctite?
I am the head of 3D printing, post-processing global in Loctite in Henkel.
Well, when I think of Loctite, I don't think of 3D printing. I think of adhesives and stuff that holds stuff together. So what is Loctite doing in 3D printing?
That's correct. So we have many years of experience in industries all around. Whatever you see all around in the car that you use, the phone that you call, or everything that you use in your kitchen, we have some adhesives inside, surface treatment chemicals or sealants. Now, having that expertise, now we are entering into additives workplace, creating all the latest technological DLP resins that we print high technological parts that can go into your manufacturing much faster.
Wait, so you're talking about photopolymers, resins that are cured, right?
That's correct.
And these are high strength?
So what we have is, for example, in this one, is the latest FST materials that we can print, that we have the flame retardancy and UL94 approved. With this material, we're going to change the way things are done in this additive market.
So this is a material that you provide for people who are making the products, correct?
Correct. And for example, aerospace, automotive, rail, these are all the verticals that we'll be seeing our materials printed in the future.
With materials, I mean, that's great, but Loctite knows adhesives as well. Do you have an adhesive solution for additive?
Let's walk together. Come with me.
I'll follow you. Oscar, you talked about your resin that has a fire retardant agent in it, but what about the cleaning solution for those resin prints?
Well, that's a very important topic because every resin printing operation has a cleaning section afterwards. And today we see a lot of flammable solvents are used. And you know what flammable means? Room temperature flammable.
Oh, I know.
And when we think about the DLP printers around the world, it's a safety issue, health issue. It's volatile, people are inhaling that.
Well, and people can develop a sensitivity to it as well.
Correct. If you inhale in time, you get some health issues. So what we did, we developed a new non-flammable cleaner that has a flash point of about 75 Celsius to get this into this market.
That's great to hear, and it's here, right?
Yeah, that is the washer equipment. So we have two stages. the one on the left, let me open it. So if you press up here, that's the cleaning section, and this is in the washing section. Why do we have two stages? Because we clean here first with our non-flammable cleaner C. This is Loctite 3D printing cleaner C, and then we move the parts into this basket where we rinse it.
Yep. Yeah. Two-stage. I know about the
stages,
two-stage cleaning.
Yeah. So when we build this into two stages, you can also build your cleaning process much faster, and you don't get in touch with the cleaner. That's all the idea.
That's cool. And is this and the cleaner available?
Correct. Right now available in US and Europe. Customers, DLP, and users can reach to us, and we will be happy to support them.
What do we have here?
So this is the universal bonder. You know, Loctite has...
Universal. Like
yeah, exactly.
universal.
Universal bonder.
Wow.
Loctite has thousands of adhesives. If we put those adhesives into this hole, people will hate us. Literally. Now, with just one adhesive, we can bond about 90% of the materials that are printed in polymer additive manufacturing.
We're talking PLA, ABS.
All of them, except polypropylene. Polypropylene is a difficult one, but yeah, we have a solution for that. Also in this kit, you have a primer and an instant bonder that we can even bond polypropylene and polyethylene.
Really?
That's correct. People also say the same feedback, like, okay, they don't believe us, they bring their parts here, and we bond them.
Wow, that's incredible because I mean I usually deal with non-industrial materials, but when you're dealing with PEEK and PEC and PEI, the solutions that are needed are they're here.
Yeah. So in this show, we brought here 638 universal bonders. These are the only ones left down. Whoever comes, we are giving one piece free, and that's all fun. And they are making their Loctite moments. We call this Loctite moments.
Okay.
And because with this small adhesive, they can fix most of their problems. And if they cannot, they know where to find a solution as well.
That's fantastic. Well, Oscar, thanks for the tour. I really appreciate it.
Thank you very much. I appreciate it as well. Thank you.
Hey, you made it this far. Thanks, because I do have something to say. We talk about 3D printing, and normally when we talk about it, we talk about the consumer-based and the hobby-based machines. But the industrial side of 3D printing and additive manufacturing is this amazing segment with thousands and thousands of people doing amazing things. If you've ever wanted to quote-unquote work in 3D printing, you should definitely look into the industrial side of additive manufacturing. There's some amazing things going on. I got to see a lot of it, and not all of it, of course, we were able to show on this episode, but we did our best, and I hope you enjoyed it. We do have some outtakes, and I'll put those in my Patreon. You can actually find a link down in the description. Sean has a Patreon as well, and he's had requests for gear, so if you're interested in the gear we took or how we filmed certain segments, he's going to break it down on his Patreon. That'll be down below as well. Don't forget to hug each other more. I do love you all. As always, high five.